My name is Nathan Thwaites, and this is my Physics 2 Lab 4 bar magnetics experiment. Introduction. The purpose of this lab is to measure the distance-dependent magnetic field of a bar magnet we were given in class, or lab. And we were going to do this by looking at the observed and predicted distances of magnetic fields, specifically the on-axis and off-axis magnetic fields. The fundamental principles that you need to know for this lab. Those principles are the Biot-Savart law, which is the relationship between the magnetic field at a point to a tiny current element. And as you can see below, the we have the formula denoted for the magnetic field of a point charge, which the magnetic field is denoted with the B constant. And we also had to know the magnetic field of a dipole and the phenomenon known as the magnetic moment, which is denoted as an M, and the distance dependence formula. The magnitude of the magnetic field due to a bar magnet decreases with distance. Now, the experiment procedures. Before I get into the steps, I also want to highlight the materials that were used for this lab above, specifically a smartphone with the magnometer app, and also a bar magnet and a meter stick. So the steps for this experiment were as follows. We had to start off by first orienting a phone orthogonal to Earth's magnetic field while using the magnometer app. Then two, we had to find the location of the magnet on the phone that we were using. And then we had to use tape in order to denote that location. And then three, we had to measure distance between the magnet within our phone and the bar magnet for on-axis and off-axis. And this is a picture of us doing it for on-axis right here. Now, after measuring it, this is some of the data that we collected in an Excel sheet, and the distances vary for the positions from 20 to 220 meters. And then this is our line of progression as well, based off of this data on the left. And it's being used to estimate the magnetic field, which shows that as you're getting farther and farther away, the magnetic field is decreasing. And then this is our off-axis analysis, and we got these calculations by orienting the phone as shown in the image. We had to make it perpendicular, and then we calculated it and put it in the Excel sheet and got these numbers here above. Now for the computational model, we had to create a function for calculating the magnetic field and what our initial conditions were. As you can see here, I created the magnetic field function below, utilizing the same point charge formula that we had in the fundamental principle slide. And then this is the computation model continued. On the left, I have the block code that I used to create the arrows for the on-axis. And then I also have on the right, I have the block code used to create the magnetic field arrows for the off-axis. And then these are the results. This purple one here denotes the 45-degree off-axis arrow, or off-axis field. And then these blue are also off-axis as well. And the orange arrow represents the on-axis magnetic field, with this white image or object representing the bar magnet. Now the assumptions made, and the assumptions and errors made. Some potential errors are: one, other magnets within the lab from nearby electronics, such as laptops and phones, could have skewed the data collected from the magnometer app. Two, we could have also been off about the placement or location of the magnet within the phone used for the experiment. And some assumptions we had to make: the bar magnet is a magnetic dipole, and the magnetic field of a bar magnet decreases over time. Now some what ifs. What if we hadn't used magnetic north and just placed the meter stick at any angle relative to Earth's magnetic field? Well, the results would likely be even more skewed than they already were, because the magnetic field seen within the Earth would interfere. And then what if we connected two identical magnets end to end and repeated the experiment? Well, since both bar magnets aren't parallel and not being observed from a location between both magnets, the fields wouldn't cancel out. But instead, the mag field would double in the same direction. This is due to them being the same strength of magnet and going the same path. I hope you guys enjoyed. Thank you.